I still have to read my sister. Sister answer. Good. Pretty much have the same thing. Give me a 15. Then planning to do it about this week.
I need to make sure that I'm studying more because
Physics or
it's really calculus, but
calculus.
But-
Is it hard?
it's not hard. I'm just gonna study. So like, I just need to. It's not easy, but it's not like hard. I just need.
Calculus feel more hard. Or
I think calculus 2 is harder.
oh,
I think like when you got to like sequences and integrals, like, I mean. Integrals aren't terribly harder than derivatives, but I feel like those are hard enough for me. Yeah, that's what I would think, so I feel like it should be there. So far, even though like that's calculus, I'm just studying and making sure.
Rachel.
Yes.
Okay, it's 4 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Hanging in there, doing good. Okay, so today's a transition day. So we're basically all wrapped up with all the classical method stuff. So basically all the content that's going to be on the midterm exam, we finished that on Tuesday. So we are moving now into kind of the second half of the course, which are all basic computer applications. Okay. So in order to do that, we'll be writing a lot of code basically from this day going forward. I thought it would be a good idea to just review some MATLAB. So this class, I think, I think at this point people are, it kind of depends on your comfort with MATLAB in terms of, how you can take this part. But, being comfortable with MATLAB is something that's going to be really important moving forward. Because not only is you kind of have to kind of learning on two fronts here. Well, on the one hand, we have the new optimization algorithms that you have to learn. So you have to know optimization and learning how the algorithms work and so on. But then the next step is to then take those algorithms and implement them into MATLAB itself, right? So it's quite a lot. And so, to try to make that second part kind of easier, I thought it'd be good just to review MATLAB. Just to kind of make sure we're all on the same page in terms of what MATLAB can do, what my style of MATLAB is, just so we can go move forward. Now, of course, MATLAB and coding in general is not something that you can just pick up in a week like that. And so I know that. We could probably spend the rest of the semester just reviewing MATLAB and it still, I think people might still walk out of the class saying that they still feel uncomfortable with it. So, the goal of the next two lectures is not to basically teach you MATLAB and try to beat up a MATLAB savant. That's kind of impossible to do in a week. But what I at least want to do is just review kind of the basic features in MATLAB, kind of, the basic kind of fundamentals of programming, the mindsets, how to track your data, what each programming statement needs, kind of just kind of like the introduction to the language. And then as we kind of introduce the different optimization algorithms, we'll come back to this again throughout the class, just to make sure everyone's still kind of feeling comfortable. Okay. Because I'm not sure if I mentioned it yet, but the final project of this class is to basically write a fairly lengthy MATLAB code to optimize a fairly realistic, engineering situation. Okay. And so of course, comfort with MATLAB is going to be important. So even though we're dedicating the next two lectures to MATLAB, this is definitely going to be an ongoing process throughout the semester. But we need to start someplace, and so that's kind of where okay. All right, so some announcements. So remember, our midterm exam is going to be a week from today, so that's going to be here in class. I think we went over the format of the midterm, which you can break the midterm last lecture. So if you haven't had a chance yet, definitely check out the recording posted on Canvas, and make sure you're working on the homework as well. So I know I posted the solutions for homework 1. I forgot I was going to scan the solutions for homework 2 today, but I left it at my house, so I need to go home and scan it. So the solutions for homework 2 will be up tomorrow. And then the solutions for homework 3 will be up on basically 10 minutes after the due date. Okay, so you'll have all 3 solutions to help you study. All right, any questions I can answer before we get started for today? Okay. All right, so today's lecture and Tuesday's lecture is kind of meant to be interactive in nature. And if you're here in the lecture, definitely open up the computer. Open up MATLAB and you can kind of follow along with the scripts that I'm writing. Okay. If you're following along on Zoom or if you're watching this on YouTube later on, definitely feel free to open up MATLAB as well. This is one of those lectures where I think it lends itself really well to the YouTube format because you can kind of pause the video and kind of go back and see what I'm typing in code. Okay. Okay. So the lecture for today is a MATLAB review. So we'll be doing this today and Tuesday. Okay. So this review here is kind of a I'm kind of reusing these slides from some other classes I take. that I teach, excuse me. And so I have a little bit in the beginning here about computational engineering. You know, we're not going to be as broad as that in this class. You know, we're kind of just using MATLAB to implement our algorithms. But you know, I think I'll just say very briefly that, you know, I think engineering and just kind of the world nowadays is kind of moving more towards utilizing computational tools to do their analysis and work. But some degree of coding skills is always going to be valuable. So we're using MATLAB in this class just because it's very education friendly. But you know, a lot of other really popular languages, Python is becoming incredibly popular nowadays. C++, I think, will always be popular. Fortran, if you haven't heard of that, that's kind of an ancient programming language. But you know, actually, a lot of engineering codes are written in Fortran as well, just because it's so old without a lot of the modern features in MATLAB of modern code that it's so fast. You have to really know what you're doing to use Fortran, but if you really know what you're doing, that's, you know, you can't really beat the performance in Fortran. So a lot of people really swear by it, but it's basically a dead language at this point. And then Julia, I have no idea what Julia is right now, but it's a more modern language that's coming. Okay, so why are we using MATLAB? You know, part of the reason is you guys have already taken a course in MATLAB, so you know it's kind of baked into our program here. The school provides you a free version of MATLAB, so that's good. But MATLAB is also great just in general as an education tool. So you know, it has a very vibrant kind of online community. There's a lot of pre-built functions that kind of simplify a lot of things. And I think, you know, compared to a lot of other programming languages, it's relatively easy to understand. And so in MATLAB, you know, I always say MATLAB scripts, you always just read them top to bottom. And so you just kind of go line by line, and you can kind of understand what a MATLAB script is doing just by reading the code from top to bottom. That's not necessarily the case with kind of a more complex language like Python and C++, where you often have to refer to different files. You have to kind of jump around a lot to kind of know what's going on. MATLAB is very simple. You just read it from top to bottom, because that's exactly how the computer is going to read it. The computer is going to read your script from top to bottom, and you just kind of interpret it that way. Okay. And this kind of goes through the same thing. Another nice thing about MATLAB is that the error messaging that it gives out is pretty, I would say, relatively useful. For the most part, MATLAB kind of tells you kind of exactly what's wrong if it doesn't like something that you did. It's all just kind of interpreting what that is. Another nice thing is that, you know, for some of the more powerful languages like C++ and Fortran, you know, you often have to worry about things like memory leaks and things like that, and those error messages are always a nightmare. MATLAB does a really nice job under the hood to kind of clean up all that stuff for you, so you don't have to really get into kind of the I call it kind of the nitty gritty of programming. You can kind of just focus on your algorithm and the logic. Okay. So that's just a little bit of background on kind of, you know, why we use MATLAB and kind of, you know, why it's kind of becoming a thing. Okay, so now we're kind of starting with the absolute basics of MATLAB itself. Okay. All right. So MATLAB, just like every programming language, is kind of centered around the idea of using variables. Okay. So a variable in any programming language is a labeled entry in a computer program that's used to store some kind of data or some kind of information, okay? And the idea is that you could store information in a variable so that later on you can either use it, or you can reference it, or you can manipulate it. And so in MATLAB, they actually make it very simple. So you can use a variable to store any kind of data that okay? The most common type of variable that you're going to use is what's called a scalar value. And so a scalar variable is just going to store a single value, okay? So actually the code snippet at the bottom of the screen is an example of a scalar variable, okay? And so here I'm defining a variable called scalar underscore example, and I'm assigning it a value of 6, okay? And so from that point forward, scalar example here is going to have a value of 6 that we can either use in an equation, or we can change it, or so on and so forth, okay? So you can see from this statement here that there's 3 aspects to assigning a variable or defining a variable. So you have to give it a name. So the first thing you have to define is the name of your variable. The next thing that you have to put is this equal sign. So the equal sign is, in coding language means assignment, okay? And then the last thing that you're gonna put is the value. And so the way to interpret this, this statement here is to say that I want to create a new variable called scalar underscore example, and I want to assign it with a value of 6, okay? So you'll hear me do this a lot where, I'm going to take computer code and I'm going to give you kind of the normal speak or the human speak interpretation of what that line of code actually does. So for me personally, it helps me to kind of interpret what codes are doing. Because a lot of times, code is kind of written away where it's kind of hard to understand. But if you take each line and kind of interpret what it's saying in kind of human speak, it kind of helps really understand code. Because if you think about it, that all a computer code really is just a list of instructions for your computer. Right? A computer program is nothing more than just you instructing the computer to do a certain a collection of tasks, right? And the way to talk to your computer or the language that the computer speaks is the code itself, right? So I think kind of helps to use MATLAB in that way, where using MATLAB to instruct the computer to do something for you. Okay. And so for our case, for this class, we're going to be instructing the computer to solve optimization problems for us. Okay, so let me open up MATLAB here. Okay. And so if you open up MATLAB, you launch the program, it gives you the following window. So there's quite a bit here. And so before we kind of get into the example of defining a variable, let's kind of take a tour of the MATLAB window itself. Okay. All right. So when you open up MATLAB, there is a few things to note here. Okay. The first thing to note here, I want to highlight is what's called the workspace. So that's this kind of area on the right. Okay. So the workspace is something that you should become very familiar with when you're using MATLAB. So the idea of using the workspace is that any time that you create a variable or you create some kind of data, their values are going to be listed here in the workspace. Okay. Okay, let me give you an example. So I'm going to type some code, right? So one way to use MATLAB is that you can use this command window in the middle here, and you can just start writing lines of code and hit enter to run. Okay? So let me type out the line of code that we had in the slides. Okay. And so the line of code that we had in the slides was scalar underscore example equal to 6. Okay. Remember what I said was that this line of code, what it's going to do is that it's going to create a new variable called scalar underscore example, and we are going to assign it a value of 6. Okay. And then I place a semicolon at the end of that line just to signify that that's the end. Okay. All right. So what I'm going to do is I'm going to hit enter, and as soon as I hit enter, it's going to execute this line of code, and then you're going to see some changes in the MATLAB console here. Okay. So let me hit enter. And as soon as I hit enter, you should hopefully have seen something update here on the right-hand side of the screen. Okay. And so as soon as I hit enter, you can see that I have a new variable here called scalar underscore example, and its value is 6, and you can check its value in the workspace. Okay. All right, so that's just kind of the very basics of MATLAB. So no matter what kind of program that you're running or what kind of thing that you're doing, you're going to be making variables, right? And that's kind of true for any programming language as well. Most programming languages are kind of variable based, and so it's all about creating variables, manipulating variables, doing computation with variables. And so getting comfortable with using variables is something that's really important. Okay. This workspace is really nice because this is kind of a feature that's unique to MATLAB. And so in most other programming language in most other programming languages, that's not going to be there. And so you kind of have to keep track of your variables by yourself. I think there might be some new iterations of Python that might have this, but but for the most part, MATLAB is the only one that does this. Okay. Now we can create more variables. Okay. And so I can create another variable called more variables. Let me assign it a value of 2. Okay. And so as soon as I hit enter here, you're going to see that it's going to create a new variable up here in the workspace. Okay. Right, and so as soon as I hit enter, you can see we have two variables now. Scalar example has a value of 6, and more variables has a value of 2. Okay, and of course you can keep going. You can keep defining variables here, but you kind of get. Okay. One thing that I'll note, and so as you start to code more and more, you're going to create more and more variables. It's not uncommon to write a code, especially for this class where you're creating, 9 to 10 to 11 different variables. Okay, it's very tempting just to save yourself on typing to make your variable names very short. Okay, so for instance, let me create a new variable called x. I'm going to assign it a value of 10. I'm going to create a new variable called y. I'm going to assign a value of 17. Okay. So it's always very tempting to use variable names that are very short. Okay, it saves you on typing and it saves you on reading a little bit too. But I want you guys to get out of the habit of using this because I would say that for people that are just beginning to program or just learning to program, this is kind of the #1 thing that causes the issue. Okay, because I always tell people that when you're coding, the amount of time that you spend typing is probably only about 5% of the time. 95% of the time that you're going to spend coding is in debugging, right? And so debugging basically means that you wrote your code, it doesn't do exactly what you want it to do, and so you are basically analyzing your code, you're trying to fix errors, and trying to get it to work. Right? The #1 thing that makes your code difficult to debug is if you use variable names that are very short like this, right? Because you can see here in this part of the code here that x is equal to 10, right? But maybe maybe if you go down maybe 600 lines later, okay. So 600 lines later, you may have a piece of code that says z is equal to x squared minus x cubed plus 3x, right? Okay. Now it's hard to imagine that because I have x that's right above that. But if you read this line of code, right? Imagine this is somewhere deep into your code, like in the middle of a bunch of for loops and if statements. You're going to read that code and be like, oh, what the heck is x here? Like, what am I doing? Like, what is this equation here? And then you're going to spend some time, wondering that. You're going to scroll up, try to find x. You're going to try to use Control F to find x, right? But it turns out you've used x, a bajillion times in other things, and so you can't really find what you're looking for, right? So don't be lazy and use short variable names. Actually put in the effort to use more descriptive variable names, right? And make use of the underscore. So the underscore is kind of your friend, and so a lot of times you want to make a space in a variable name, but a variable name needs to be all one word, all one contiguous word. So using an underscore to keep that word together, but still break apart different words of your variables is something that's really helpful. Okay, any questions on variables here? Okay, good. Okay, so let's come back to the slides here. Okay, so now that we have variables, we can use them in calculations, right? So we can define equations, we can define formulas that use that variable, and it'll basically take on the value that it had from it, right? Okay. So actually, let me come back up here. Let me clear the space. By the way, if you're working in the command window here, you can you can clear some space. You can wipe out the command window by running the code CLC. Okay. So if you type CLC and then you hit enter, that's going to clear the command window of all those commands, right? So just to kind of clean things up for you. If you want to wipe out the workspace, and so you want to clear this out, and so you want to clear out the memory, you can type out the command clear all and hit enter. Okay. So once I hit enter here for clear all, it's going to delete all of these things in the workspace. Okay. And so if you ever want to start with a clean slate, clear all in CLC is always helpful. Okay. Okay, so let me go ahead and make the variable again. So we're going to need scalar example. Set value to 6. Okay. Okay, and so now I'm going to create a new variable. Right. So I'm going to create a new variable called scalar underscore operation. Type out the word underscore. So scalar underscore operation, and so we're gonna give this a formula, okay? And so the formula that we're gonna give it is 3 times scalar example plus scalar example. And so you can see that, once again, we're creating a new variable. And so this new variable scalar underscore operation, this is going to be a new variable that's going to show up in the workspace. But instead of assigning it a value from, scratch, we're assigning its value based on the outcome of an equation. Okay. Okay. And so that equation that we're going to do is 3 times scalar example plus scalar example. And so the way to interpret this is that, whatever value that scalar example has, we're going to plug it in here. Okay. And so we know scalar underscore example has a value of 6. And so this can be 3 times 6 plus 6. And so that should be 24. So as soon as I hit enter here, you're going to see a new variable pop up here called scalar underscore operation. And it's going to have a value of 24. Okay. And that is exactly the case right now. All right, good. All right, so this is really useful, right? And so, not only when you can you create variables, you can also, from scratch, you can also create them based on the values of other variables, right? And of course, this is a very, very common operation that you can do Okay. All right, so we can also define vectors in the same way. And so, oftentimes we may want to use vectors. This may not be as common in this class just because, we're doing optimization. So a lot of times, we just are using scalar variable. But vectors can also be useful as well. Okay, so just to kind of give you an example, we're going to create a new variable here called a vector underscore example. Right, so I'm using the exact same syntax here. So I'm creating the name of the variable. I'm using an equal sign. So the equal sign defines assignment. And then to make a vector, you can see here that I'm using square brackets, right? And so an open square bracket basically tells MATLAB that, I want to make a vector in this point, okay? And so a vector is basically just a collection of different values separated by commas, right? And so in this case, I'm making a vector with 3 entries. The first entry being 7, the second entry being 1, and the third entry being 4, right? And so vector underscore example is going to be 7, 1, 4. Let me hit enter just to show you what that looks like. By the way, you can double click on these to kind of view their values. For a scalar, it's not really important just because you can see it here. But when we start to have vectors that have very long, amount of entries, it may be useful. To kind of view the entries here. Okay. So you can create vector variables in the same way that you create scalar variables as well. And of course, you can perform operations with them as well. Right? So you can do vector addition, vector subtraction, vector multiplication. You can even do that too. Okay. And so you can do all that using. Okay. Any questions on this? Okay. Good. Okay. MATLAB also has some special functions, and so oftentimes we want to create data structures that have a certain pattern, right? And so there are a couple interesting commands here to know. So one of them is called linspace, and so the linspace is actually a command that I'm finding myself using a lot more. Okay. So linspace is a command that will create a vector, and the way to and the entries of that vector are going to be a sequence of numbers that are equally spaced apart. Okay, so the way to interpret this, so the command linspace is a particular MATLAB command. So this is kind of our first time kind of seeing a MATLAB command as well. Okay. So whenever you're using a MATLAB function or a MATLAB command, you almost always have to give it some kind of input parameters. Okay. And so the input parameters are given by, the numbers that are within parentheses. Okay. And oftentimes you have to separate different parameters by commas. So linspace is a special command that takes three inputs. Okay. The first input here is called the starting value. The last, or the second entry here is called the last value. Okay. And then the third entry here, this is the number of entries. So the way to interpret this is that, this line of code, what it's doing is that it's telling MATLAB that I want a new variable called linspace underscore example, right? And I want it to be a vector that goes from 0 to 10, right? So the starting value should be 0, the last value in the vector should be 10, okay? And I want this vector to have 5 different entries, okay? And so if you run that code, this is kind of the result of that code, okay? And so with linspace example, you can see here that we have a vector with 5 entries. Okay, so 1, 2, 3, 4, 5. The first entry in the vector is 0, the last entry is 10. And then every other entry in the vector is equally spaced from each other, right? So we go from 0 to 2.5. The difference between 2.5 and 0 is 2.5. We go from 2.5 to 5. Once again, the difference between those two is 2.5. We go from 5 to 7.5. The difference is 2.5. And then to 7.5 to 10, once again, the difference is 2.5. So oftentimes, there might be cases where you want to create a vector here that is basically, that has kind of equally spaced entries, okay? And linspace is kind of a special command to do it. Another useful command that we'll probably use a lot in this class is the zeros command. And so the zeros command is a special command that creates a vector of all zeros. Okay. And so oftentimes, when we're running a particular algorithm, we may create a vector that has, a bunch of zeros in it. Okay. And so this is kind of just a very, very quick way to do it. Especially if you want to create a very large vector of zeros, this is kind of the most efficient way to do it. And so once again, you can see that this command zeros is a special MATLAB function. Okay. You can tell that it's a MATLAB function because it has these parentheses. Okay. So every MATLAB function comes with a parentheses for the input arguments. Okay. And the interpretation of these input arguments is that, this zeros command is going to create basically it's going to create a matrix where this first entry here is the number of rows. Okay. And the second entry there is the number of columns of the matrix. Okay. And so in this particular case, we're creating a vector because it has 100 rows and only one column. So it's a column vector with 100 entries. Okay, so let me kind of show you that in action just so that you can see. Let me go ahead and clear this out. Okay, so we have an example here, zeros example. So I'm creating a new variable here. I'm assigning its value using the equal sign. And I want the zeros vector to have 100 rows and 1 column. Okay, so let me hit enter. Okay, so you can see after I hit enter here, it created the variable and it populated the workspace here. Okay. And if I double click this, you can see all the values in this vector. So you can see it's all zeros, right? All the way down to entry 100. All right. So the zeros command, if you kind of trained in if you kind of learn programming from like C++ or Python, the zeros command is probably something that you're going to use a lot. Because oftentimes in those languages, when you create a vector and you create a matrix, by default, it creates everything in zeros. And so, all the algorithms that you write or that you're trained to write kind of is under that assumption. So for myself, I first learned programming in C++, and then I learned MATLAB, and then I learned Python. And so, just for my own personal style, I end up using the zeros command a lot, just because, that's basically how C++ creates matrices. All right, any questions on these special commands? So either linspace or zeros? Okay, So now let's move on to manipulating variables, okay? So once you set the value of a variable, you can change it. And so it's not something that's kind of set in stone. In fact, basically all of our algorithms are going to rely on this fact that we can manipulate the values after we set them, okay? So if we look at this code here, okay? So let me go ahead and clear CLC. Okay, so let's create a new variable here called scalar underscore example, and we'll assign it a value of 9. So that's our first variable there. We can then change the value of that variable using code. Okay? And so just a very simple example is that we can reassign the value of scalar example with another line of code. Okay, so let's say that I want to, either change my mind or maybe something later in the algorithm requires this variable to have a different value. Okay, and so let's say I want to change the value of this variable to 15. Okay, and so if I have this line of code right after the first line, what it's going to do is that it's going to basically overwrite the value of 9 and then replace it with 15. Okay. Okay. So kind of pay attention here. And so on the right now, you can see that our scalar underscore example has a value of 9. As soon as I hit enter, its value is going to change to 15. Okay. Okay. And so this use of the equal sign is slightly different than what we had from before. It may look basically the same. It kind of is the same. But we're using the equal sign in this case to reassign the value of the variable itself. Okay. So we're not creating a new variable here. This variable scalar underscore basically already exists. We're just updating its value to be something that's more appropriate. Okay. Okay. And then you can do operations with this as well. So we can do this line of code right here. So we make a new code here. So do new underscore variables equal 7. Okay. So you can see that created a new variable that had a value of 7. Okay. I can create another variable called whodis and then assign it a value of 2. Okay. Right, so that's 2 variables that we have there. But let's say that we want to manipulate or reassign the value of a new variable based on the value of this on whodis. Okay. Okay. So what I can basically say is that new variable is equal to. Okay. So if I want to change the value of the variable to whodis, in fact, let's make it interesting. Let's put in an equation on it. Okay. So let's change the value of new variable to be 3 times the value of whodis. Okay. So what I'm going to do is I'm going to plug in the value of whodis, which is 2, into this equation here. And then our value for a new variable is going to be 3 times 2, which is 6. Okay. So once again, kind of pay attention to what's happening over here. Once I hit enter, you can see that its value has changed to 6. Okay. So, don't be afraid to kind of reassign values of your variables, okay? In fact, a lot of the algorithms that we're going to do are going to be, are going to rely on this, okay? Okay, another really interesting way to update or manipulate the values of variables is to use update notation, okay? Now, if you read this line of code, it may look confusing a little bit, right? And so on the one hand, we can see that we're doing a variable assignment. So we have a variable name and an equal sign, right? So the fact we have a variable name and an equal sign means that we're going to be either changing the value or creating a new variable, or maybe changing the value of a certain variable, okay? But you'll see that this variable kind of shows up on both sides of the equal sign. Right, so we haven't seen this before. So we've seen cases where we change the value of one variable based on the value of another variable. Okay, but having the same variable on both sides of the equal sign can be a little bit tricky at first. Okay, all right. So you'll see this line of code being used whenever we want to update the value of a variable based on its old value. Okay. Okay, so once again, the way to kind of read this statement here, in kind of plain English speech, is to say that the new value of this variable whodis is the old value of whodis, and so this is the old value before this statement, plus 9, okay? And so basically this is saying that whatever value is in whodis, whatever number is there, we're going to add 9 to that, and then we're going to save that result into whodis and overwrite the previous value. Okay, so I'm going to come to MATLAB here. So right now our whodis has a value of 2. Okay. And so let's say that I want to change that value to the previous value plus 9. Okay, so if I type out this code, whodis is equal to whodis plus 9. Okay. So what this is going to do is that it's going to reassign the value of whodis, and that value is going to be reassigned to whatever was in there previously. Okay. So before we execute this statement, whodis has a value of 2. Okay. And then to that, we're going to add the value of 9. Okay. So when I execute this code, the value of whodis is going to change, right? And it should change to a value of 11. Right? And so what we're saying is the new value is equal to 2 plus 9, which is 11. Okay, so let me hit enter. Okay. And you can see that now the value for whodis is 11, right? Which was 2, which was its previous value plus 9. This line of code or this kind of style of coding right here is really useful because a lot of times, you're going to be repeating this and you're going to be continuously updating the value of a variable as we kind of go through an algorithm. Okay. Because watch what happens when I repeat this line of code. Okay. By the way, if you didn't know this, if you want to repeat a line of code from the MATLAB console, one easy way to do this is that make sure that you are selected in the command window, and you can hit up and down on the keyboard. Okay. So MATLAB actually keeps a history of all the commands that you've run so far in the command window. Okay. Okay, so let me repeat this line of code. So it's the exact same line of code that I had before. So whodis is equal to whodis plus 9. Okay. But ever since we ran this this original line of code, the value of whodis is updated, right? And so when I run this line of code, the value of whodis is now going to be 11. Okay. And so now we're going to assign a new value for whodis, which is 9 plus 11, okay, which should be 20. Okay, so once again, kind of pay attention to what's happening over here. I'm going to hit enter on the keyboard. Okay. And you're going to see that the value of whodis be updated to 20. I can keep repeating this. Okay. And so every time I repeat this, it's going to add 9 to whatever value was in whodis previously. Okay. So now this is going to turn whodis to 29. Okay. I add another 9. We have 29 plus 9, which is 38. Okay. I can just kind of keep going and going and going. And every time I repeat this line of code, right, the value of whodis gets updated, and we add 9 to it. Okay. Okay. So this idea here is really useful because oftentimes, especially in optimization, we're going to be using for loops quite a lot. Okay. And so oftentimes, maybe you want to update the value of a variable within the for loop, right? And so this is kind of one way to kind of keep track of what the old value was, but then update it to your new. You can also subtract. You can have whodis is equal to whodis minus 20. Right, and so this again kind of updates the value of whodis, and so it's going to be minus 20 to what it was before. Okay. You can see once I hit enter, this value of whodis on the right-hand side is going to change to 135. Okay. I repeat the line, it's going to be 115. I repeat the line, it's going to go down to 95. Okay. So on and so forth. You can also do multiplication, so you can do multiplication with this update notation, and division too, of course. All right. Any questions on this kind of update notation here that we're using to update the value of a variable? Okay, cool. Okay, so let's come back here. Okay, so let's take a break from the MATLAB and kind of talk about how variables are used. Okay, it's a little bit hard to illustrate here, just because of I'm just typing just kind of relatively random lines of code. But typically, when you are writing a MATLAB program or a MATLAB script, you're doing it with the objective to, well, for our class, you're doing it with the objective to execute an optimization algorithm, okay? And so variables are going to be used throughout the script, to either keep track of variables or to keep track of calculations, do things like compute objective functions or compute constraints, things like that, okay? Okay. So the first use of a variable is to just permanently store some important problem parameters, okay? So let's say that you have some fixed parameters in your optimization and you want to save its values into a variable. You can do so, using that variable. Okay. So this first use of variables is to store what I call kind of, permanent variables. So these values are often, they often represent, system quantities that are not really going to change. And so you can use them to kind of permanently store values. Okay. MATLAB is a little bit loose on this. And so in other programming languages, it's possible to define a variable and just tell the program that this is never going to change. You can do that very commonly in C++. And so the way to do that in C++ is to use a command called const. Okay. In MATLAB, there's no such thing as that, or there might be. But, so you kind of have to keep track of this by hand. Okay. Okay, so another important use of variables is to store, is to do what I call kind of temporary storage. And so a lot of our algorithms that we're going to be using are going to be, require the computation of certain things, computations of objective functions, constraints, things like that. Okay. And so you can use variables to kind of store these results just in a temporary fashion, and then use them later. Okay, well, I forgot I had this part in the slides, but just another caveat. Make sure you use distinct and descriptive names for your variables. Don't just use single word or single letter names like X and Y. Okay, because if you do that, you're going to end up with a lot of profanity in your code, like that. And this is fine too. I mean, this is very descriptive. It kind of expresses the anger and frustration that you're feeling in the moment. But obviously not so helpful for debugging your code. Okay. All right, so I'm going to kind of breeze through this part here just because, matrices are not going to be super relevant for kind of what we're doing for our algorithms. Again, for the most part, our variables are going to be limited to mostly scalars and vectors. But, there may be an off matrix or two. I'm running through all the algorithms that we're going to use in this class. I don't think any of them use matrices. But matrices is actually one of the, I would say, the premier features of MATLAB, that you can kind of define them so easily. Not all programming languages have this, and so in fact, a lot of programming languages using matrices is kind of a big hassle. So the fact that MATLAB can do this is a big tool. Okay. So you can define matrices like this, and so you can do it kind of line by line. And so you can see with this example here, we're defining the first row of the matrix, the second row, and the third row. Okay. You can also do individual assignments. So you can create what's called an empty matrix or an empty tensor. Okay. So you can use the zeros command, and you can individually assign the values for each of those entries in the matrix. Okay. And so once again, when you create a matrix, or when you create a vector, each entry in the vector or matrix, you can kind of consider to be its own individual variable. Okay. So you can manipulate the entries in the matrix, you can manipulate the entries in a vector to have certain values, and you can do it in the exact same way that we did before. Okay. So basically you can call upon an entry in the matrix and you can assign its value, okay, or you can manipulate it, you can change it, you can update it. This is kind of the way to do it. Okay, so again, we're not going to do too much with matrices in this class. Most of the programming that we're going to be doing in the class is kind of logical in nature, and so we're going to just be using variables and scalars and vectors. Okay, so I'm going to skip all this stuff. This is mostly kind of irrelevant. Okay. So that's kind of the very basics of MATLAB, right? So you can use MATLAB, you can define variables, you can manipulate its values, and you can change them and so on and so forth. Okay, so Now we're getting to some of the more complex features in MATLAB. Okay. Actually, before I do this, let me go over something that's actually really important. Skip it over. Okay. So far in MATLAB, or at least kind of what I've demonstrated in class here, is that we're using MATLAB in what I kind of call command mode. Okay. And so in command mode, you're basically inputting the lines of code one by one, and MATLAB is basically executing these lines of code kind of in real time, right? And so you type a line of code, you hit enter, MATLAB executes it right away. This is not very typical. So typically, you don't use MATLAB in this way, just because it's kind of a little bit cumbersome. It's a little bit hard to do something complex with this style of code. Okay, so let me go ahead and clear this. So the typical way that you use MATLAB is that you write a MATLAB script. Okay. So probably in your previous classes in 205, or if you use MATLAB in 407, 333, so on, this is probably how you use MATLAB. Okay, so to make a new MATLAB script, you can open up the MATLAB console and you can click on new script. Okay. And what that's going to do is that it's going to open up a blank text file for you. Okay. Now, in this text file, it's similar in the sense to command mode, in the sense that you can write each line of code one by one. Okay. So let's say that I want to create variables here, scalar underscore example 7, okay. New variable equals 90. Okay. Right. So I'm typing these lines of code, but one thing you'll notice is that the workspace here isn't updated, right? So before, when we type things in command mode, as soon as I typed a line of code, and as soon as I hit enter, MATLAB is going to execute that line of code. When you're writing a MATLAB script, right, you're basically free to type whatever kind of commands that you want, but MATLAB is not going to execute your code until you basically tell it to run. Okay. Okay. So you can see I'm typing these lines, and so maybe you want to update the value of scalar example. So scalar example equal to scalar example plus 4. Okay. Okay. So to actually execute these lines of code here, I have to run this script. Okay. And so it's a little bit covered by my Zoom thing here, but you should see there's kind of a big green arrow within MATLAB called run. Let me go ahead and run this code. It's going to ask me to save it. Right? Every time you run a MATLAB code, it kind of automatically saves. Okay. So I'm going to call this MATLAB test code. Okay. And so you can see that as soon as I ran the code, it executes every single line. Okay. So a script is nice because, oftentimes, you want to write, especially when we get to the more complex algorithms, you want to implement the entire code first before you actually start executing lines. Okay. And so scripts are kind of a great way to do that. And so you can see here that I typed 3 lines of code. As soon as I was ready, I hit run, and then MATLAB basically executed these 3 lines of code from top to bottom. Okay. So it did scalar examples equal to 7, new variables equal to 19. Okay. And then execute this on line right here. Scalar examples equal to scalar example plus 4. Okay. All right. So scripts is something that's really used. And another nice thing about scripts is that it saves your work. And so you can of course open it up later and continue working on it. If you type things out in command mode, those lines of code are not saved at all. And so you're basically going to lose all your work. So writing in scripts is something that really really. Okay, but I wanted to take this opportunity to kind of illustrate something else to you. Okay, and so if you look at this code here, you can see we have one line of code that says scalar example equal to 7, right? But if you look on the right-hand side of the screen here with workspace, you can see that scalar example does not have a value of 7, it has a value of 11, right? So why is that? So the workspace only shows you the most recent value of all the variables in your code. Okay? And And so if you have, if your code is going to update the value of a variable somewhere lower down in the code, then it's only going to display that value for the variable. So even though we type scalar example up here, is equal to 7, we don't actually see that illustrated in the workspace because, we have a more recent line of code or a later line of code that updates its value. Okay. Now, that's not to say that this line of code is useless. In fact, you can see that it actually plays a very crucial role in determining the final value for scalar example. Okay. Because you can see our final line of code here is scalar example is equal to scalar example plus 4. Okay. So its ending value here, which is 11, you can see it obtained that by doing 7 plus 4. Okay. So, when you're kind of reading your MATLAB code and you're kind of interpreting it, right? Remember I told you it's important to kind of read the code from top to bottom. Okay. So from lines 2 and line 3, right? So line 3 is blank, but just for the sake of argument, you can say that we're kind of in that spot. Okay. From lines 2 and lines 3, the value for scalar example was indeed 7. Right, so there was a very brief period of time in this program where scalar example had that value there. Okay. Of course, in line 4, we're changing that value, right? But for a very brief period of time, it did have a value of 7. Okay. Usually, when you run these scripts, it happens so quickly that any kind of intermediate value you never really kind of see reflected. And so, we can try to run this, a million times, and our eyes are never going to be fast enough to see the value of 7. So you can see I'm running it, and it still kind of stays up. All right. Now, if we were to update it again, right? So if I say, maybe I repeat this line of code right here. Okay. So if I repeat that line of code, and you can see that, and when I run it again, you can see that scalar example, its value is changing 3 times, right? So first it's being set to a value of 7, then it's being set to a value of 7 plus 4, which is 11. Okay. Then I'm changing the value again to 11 plus 4, which is 15. You can see I'm running the code, lots of times, but the only value that's displayed in the workspace here is 15. Okay. All right. So this is important to know because when you guys are writing your code, this situation here is going to happen a lot, where you're going to define a variable, you're going to change its value, you're going to update its value in the code, right? So when you're kind of updating the value of a variable multiple times in the code, of course that's not going to be that's not going to be illustrated in the workspace here. And so in these situations, you kind of have to use your brain to kind of keep track of the value of a variable yourself, right? And so this is kind of where programming starts to get tricky, where even with MATLAB that MATLAB has a lot of tools for you to keep track of certain things, but there are some things that just kind of happen too fast for MATLAB to kind of show you. So you have to keep track of the values yourself. Okay. Okay. And so in this code, the only way that you would know that scalar example at some point had a value of 11 would be for you to kind of read this code yourself and kind of interpret the code yourself. Okay. And so just by reading this code just as a human, we can see that after line 4, scalar example very briefly had a value of 11. But then as soon as we got to line 5, that value of 11 was overridden to a value of 15 instead. Okay. Okay. And so as you write more and more MATLAB scripts, the more complex your scripts get. We're going to be writing scripts in this class that have 300, 400 lines of code. And so being able to track your variables and track its values is a very, very important skill. All right. Any questions on this? Okay. All right. So using a MATLAB script is going to be important for this next thing that we're going to do, which is if statements. Okay. All right. So now that we know how to execute kind of basic code, right? We're ready for kind of more complex stuff. Okay. Okay. So if statements are used throughout a lot of programming just in general. And the idea with if statements is to provide basically basically what's called conditional programming, where you're basically telling the program to do different things depending on different scenarios. Okay. And the way it works is basically this. And so when you write if in a code, you can see if is highlighted blue. And so that tells you that if is some kind of special command or special characters within MATLAB. Okay. When you write if, you're going to provide it with something called a check condition. Okay. So a check condition is what's known as a Boolean statement, and it's basically a condition that can either return true or false, yes or no. Okay. And then based on the outcome of that statement, you can tell MATLAB to do a certain thing, or you can tell it to do something else. Okay. So the most basic structure of an if statement is to say if the check condition, you're basically saying if this check condition is true. If it's true, then come inside of the if statement and execute this code. Okay. If it's false, then what we're going to do is we're going to skip over this these codes entirely. Okay. Okay. So you're going to tell the code base to do something if it's true, or just skip it if it's false. Okay. Okay. So I have a couple of examples for you. So let me come back to MATLAB here. Let me come into the script. Okay. When you're using MATLAB scripts, if statements are essential. Okay, so let me define a new variable here. So let me define a variable called needs_correction. And we're going to set its value to 3. Okay. So we're creating a new variable here. Then I want to write an if statement to update the value of this variable, if it satisfies some sort of conditions. Okay. So we're going to write if. Okay. I think you can do if statements without parentheses, but just force a habit of mine. I've always learned that if statements use parentheses. So I always write parentheses, but if you prefer not to, that's fine too. Okay. Okay. So now we need to input a statement here that's going to return true or false. Okay. The most common way to do this is to use comparison operators in math. And so that's a less than or greater than, less than or equal to, greater than or equal to, or you can use a double equal sign to indicate equals to. Okay. And so the condition that we're going to check is that if our variable needs correction is less than 5, then what I'm going to do is I'm going to update its value. Okay, so if it's less than 5, I'm going to update its value to 5. Then I'm going to end the if statement. Okay. So every time you write an if statement, there has to be an if and there has to be an end. So the end is basically there to signify to MATLAB that that's the whole command I wanted input in this section here. Okay. All right. So let me actually go ahead and clear the workspace too. Can I do CLC? Okay. Okay, so before we run this code, let's kind of read it through and let's kind of interpret it ourselves. Okay. So you can see we're defining a new variable here called needs correction, and we're giving it a value of 3. Okay. Then we're writing an if statement. So if the value of needs correction is less than 5, then we're going to correct it to a value of 5. Okay. And so, based on what we see here, we can see that this if statement here is going to return true. Okay. Great. Because the value of needs correction at that point in the code is equal to 3. Okay. And 3 is indeed less than 5. And so since 3 is less than 5, we're going to enter into the if statement here. Okay. And then we're going to assign needs correction to a value of 5. All right, so when we run this code, it's going to be clear here that needs correction is going to have a value of 5. So you're going to see needs correction here show up in the workspace. Once again, you're not going to see needs correction have a value of 3 because it only has a value of 3 between lines 2 and 3 here. As soon as we hit line 4, it's going to update to a value of 5. Okay, so let me go ahead and run the script. You can see here that we have our variable needs correction, and it indeed has a value of 5 because we entered into that if statement and we changed its value to. Okay, so that's the basics of an if statement. And so if statement basically lets you write your program to account for different scenarios, right? So to do one thing in certain scenarios, or maybe do something else in another scenario. Okay, so how we're going to use this, and so a lot of the optimization algorithms that we're going to cover later on have what I call kind of branching decision paths. And so maybe depending on the value of your design variables at that given point, or maybe depending on the value of your objective function, you may want to do one thing, right? Or you may want to do another thing. Right? So the if statement is kind of your way to kind of split the decision and kind of do something that makes sense. All right, any questions on just the basics of if statements? Okay. All right, so let's see what happens when an if statement returns false. And so I'm going to use the same code, but I'm going to change the initial value for each correction to 8. Okay. So the code is almost exactly the same. The only thing I'm changing there is the starting value for each correction. Okay. So once again, we can kind of read through this code right here, and we can interpret it the same way. So once again, we hit up to this if statement, and so we're going to check to see if the value of needs correction is less than 5. Okay. But now needs correction has a value of 8 because we changed it. Okay, so we check if 8 is less than 5. 8 is not less than 5. 5 is actually less than 8. And so this if statement here is going to return false. Okay. And so when an if statement returns false, then we don't execute anything that's on the interior. Okay. And so when we run this code, our variable needs correction here should maintain its initial value of 8 because we do not reassign it within the if statement. Okay, so I'm going to go ahead and run the code. And then indeed, you can see here that our final value for needs correction is 8, even though within the if statement we have this line of code here, needs correction is equal to 5. Okay, but the program never sees that line of code because it checks this conditional and it returns false. Okay. Okay. Any questions on this? Okay, good. All right, so that's basic if statements. A variation on the if statement is to do what's called an else if statement. Okay. And so, it happens a lot in programming when you write an if statement, and your first condition here is going to return false. Okay, just like what we had before. In those cases, if your initial if statement returns false, then you can have the if statement check a second conditional and do something else if that one returns true. Okay. Okay, so reading these can be a little bit tricky. And so, when you have an else if kind of exists within the if statement from before, right? And so it's all encapsulated between the if and the end. Okay. The if always signifies the beginning of an if statement. The end always signifies the end of the if statement. Okay. And everything in the middle gets executed depending on the values of the conditions. Okay. Okay. So we have a few different scenarios here. So if this first condition here returns true, then what we do then is we execute this whatever is directly underneath the if statement. Okay. But then we don't do anything else. Using an else if statement is basically saying either or. So either we're going to do this stuff if it's true, or we're going to check this and do that other. So that's scenario 1. So scenario 1, maybe the first part of the if statement returns true. And so if the first part of the if statement returns true, it doesn't matter what's listed later. We're not even going to execute. Okay. The second situation that may happen is that maybe condition 1 returns false. And so maybe if condition 1 returns false, we're going to ignore the first part there. And then we're going to check condition 2. Okay. If condition 2 returns true, then we're going to do the work that's within that part right there. Okay. But what if both conditions here are false? And so condition 1 is false, condition 2 is false, right? If both of those conditions are false, then we ignore the entire thing. Okay. Okay, so let's kind of illustrate that in MATLAB here. Okay, so I'm going to use the same thing here. So within the if statement here, I'm going to type else if. Right. I'm going to say else if needs correction is greater than 11. Okay. Then needs correction is going to be set to a value of 11. Okay. All right, so let's run through a few different scenarios here based on the value, our initial value of needs correction. Okay. Okay. So let's say that our value for needs correction, let's go with 8. Okay. All right, so we're going to check both of these conditionals here. So we're going to check this first conditional. We're going to check if needs correction is less than 5. So we check the value needs correction here. So we have a value of 8. And so 8 is not less than 5. And so this first part of the if statement is going to return false. Okay. So we don't execute any of these lines of code here at all. Next thing we're going to check in the else if statement is that we're going to check else if needs correction is greater than 11. Okay. And so once again, we're going to check the value for needs correction. Okay. We can see that needs correction has a value of 8. 8 is not greater than 11. 8 is less than 11. Okay. So this else if part is also going to return false. And so we have false, false for these. And so for this code, our value for needs correction is going to stay put at a value of 8. Okay. Let me clear this just to kind of illustrate to you. All right, so when I run this code, needs correction should have a value of 8. And indeed it does. Okay, so let's try another value. Okay, so I'm going to change the value for needs correction to 3. Okay. All right, and so with the value of 3, once again, we're going to run through our if statements here. So we're going to check if the value of needs correction is less than 5. Okay. Needs correction is less than 5, so we have a 3 there. Okay. And so since this first statement here returns true, we're going to execute this line of code right here. And so we're going to update the value for needs correction to be 5. Okay. And then since this first section of code here was true, the code is not even going to execute these lines of code down here. Okay. Now I know in this case, that second bunch of code in the needs correction, it's going to return false for that anyway. But the way to kind of interpret it, the code doesn't even see this because the first if statement returned true. Okay, and so when we run this code, our value for needs correction should have a value of 5. Okay. And so you can see that as soon as I ran the code, the value for needs correction was updated to 5. Okay, one last trial. We're going to try it with a value of 13. Okay. So once again, we're going to check both conditionals there. And so first we're going to check if the value of needs correction is less than 5. Our value for needs correction at this point is 13. 13 is not less than 5, and so we're going to move on from that part. Then we're going to check the else if, and so we're going to check else if needs correction is greater than 11. 13 is indeed greater than 11, and so we're going to execute this line of code, and then our variable should have a value of 11. Okay. And indeed it does. Okay, so after running this code, our variable there has a value of needs correction. Our variable has a value of 11. Sorry. All right. Any questions on the else if statement? Okay. All right. So the next thing in this lecture slide is the else statements, but we're just about out of time. I don't really want to start this and kind of rush it. And I kind of want to talk about the conditional statements a little bit. We can even more structure as well. So let's stop here for today. So when we come back on Tuesday, we'll finish up these slides here on the MATLAB review. So we'll go over else statements. We'll go over for loops. For loops are incredibly important for the algorithms, because all the optimization algorithms are iterative in nature, okay? And then what we're also going to do next class is we're going to do a bunch of examples. And so I have a few examples here, and then we're going to do some, I would say, kind of fake algorithms, fake optimization algorithms next time. Just to kind of give you an idea of, what our codes are going to do. All right, so thank you guys for coming today. Hope you guys have a good rest of your day. Hope it's a good weekend. Best of luck studying on the exam. Remember, the exam is next Thursday, so make sure you are prepared for that. And I will see you guys next week.
Professor? Professor? Professor?
Yep.
I had a question for on the homework.
Yep.
For number 2C, I'm not sure what the objective function is. I'm a little stuck for that. Or the constraint. I got the objective function. Yeah, that one, the cylinder one.
Yeah, so the constraint of this
The one
case-
under that, the tree trunk.
Oh, 2C.
Yeah.
Okay, yeah, so this one's actually quite similar to the one we did in class with the, with the sphere and the box. So basically your constraint is that your cut here, or your rectangle, has to fit within the circle. So it's a little bit implied here, but the way to get this to fit in the circle is to basically make sure that those diagonals is fitting in. Okay. So basically, if all four corners of your rectangle are fit within this the circle, then your entire cut will be just fine. So if you notice here, if you draw a line from the middle of the rectangle out to the circle, this is the radius, right?
Yeah.
This is also a line that goes from the middle of the rectangle to the corner. And so actually, if you connect these two, right, so you kind of make one really big diagonal, and you can make a triangle that kind of looks like this. Well, it should look better, but you get the idea. We know the horizontal length of this, which is W. We know the vertical length here, which is H. And the hypotenuse of this triangle is going to be 2 times the radius. And so this triangle basically has to exist in this proportion here in order for your rectangle to fit. And so you can use Pythagorean's theorem here to create that relationship. So basically W squared plus H squared is equal to quantity 2 times R squared. And so your W's and H's have to basically satisfy this relationship in order to fit within the circle. So this right here is your constraint.
Okay. And then for the objective function, I just want to double check. Is it just the perimeter? Is that what it was?
Yeah, so the perimeter is just 2 times H plus 2 times W.
Got it. Sounds good. Thank you.
You guys have a question too?
Yeah. That was one of mine. Kind of trying to compare between the class nodes. I was trying. So I came up with this. I don't know if it's right.
Yeah, no, that's right. So in this problem, you have a total budget of 90,000, right? So the total amount that you're paying for advertising is can't exceed 90. So for this one, you have 2 options for advertising. You can do newspaper ads for 1,000. That's represented by X, and then you can do TV commercials for 2,500. And so depending on the numbers of newspaper ads and commercials, that has to add up to 90. So this is exactly the constraint.
Okay, yeah, I wasn't sure. I have come up with a couple. And then this for I think of our time with figuring out the constraints. I guessed this because I know, like in last example, it was flipped. Like this was our objective function, so I just kind of. Wait, is this correct?
Yeah, no, that's
Okay,
right. Yeah,
okay.
so the way to kind of read these problems that whenever you have, so the key word here is must, right? And so when something must happen, then that's basically a constraint.
Okay.
And then it's just kind of putting those words into an equation. That's kind of basically doing that's and you did it perfectly. So that's
Okay.
exactly what it is.
Okay,
Yep.
thank you. Yeah, I was having a hard time. I wanted to make sure. Okay, thank you.
Yep.
And then you said this one was 2H2.
Yeah, so for that one, you are, I believe you're maximizing the perimeter. Yeah,
Yes.
so the perimeter of a rectangle is just H plus W plus H plus W. So
Okay.
2H plus 2W.
Okay.
Yeah.
Thank you.
Yep. Mhm.
Hey, Professor, I had a quick question. Pretty random, if you don't mind.
Sure, no problem.
Um, for spring 2025 of this year, do you know when the commencement date is for mechanical engineering specifically?
I don't think I don't think they've announced it yet. Let me check for you.
Okay.
So there's a website for commencement.
Yeah, I was looking at that. I believe it said the 21st, but I'm not sure if that was for last year because I think the 21st fell on
It might have been. Um. So I don't think they posted it. So this is the website. So Fullerton.edu/commencement. As soon as they do have the schedule for us, then I think they'll probably update this website. You can try to contact them. They may know something.
I'll do next.
So our representative for commencement is going to be Sandra. So you can send her an email and just say that, do you happen to know what day of the week that our graduation or commencement is going to be? And then if she knows, then she'll let you know. But I don't think they did let the public know what day it is.
okay. Do you happen to know when they'll release it by chance?
Usually in the spring semester. So usually start of spring semester they'll.
Okay. Okay, no worries. All right. Thank you, Professor.
No problem.
Have a good day.
You too.